So hello everyone, thank you for your time. My name is Elisel Espinal. I'm currently located in Maryland and I'm an environmental engineer with GHD. Um, for today's agenda, I'll be focusing on a bit overview of the project background and the 4 phases that were taken to provide some PFAS analysis and evaluation, which include basis of design, treatment alternatives, treatability testing, full-scale pilot test plan, followed by recommendations and conclusion. Now, a little bit about the project background. The client is a municipality owner located in the Mid-Atlantic region. It is a private client, so a lot of this information is minimal and proprietary, so that's why there's not too much detail. But however, they were requested by their state regulator to perform PFAS analysis at their water treatment plants, and one of their water treatment plants was detected with EPA, with limits above the EPA standard, which is the 70 parts per trillion for PFOA and PFOS. In this existing treatment facility, it's fairly simple. They have a 10 horsepower well pump, and that gets split into raw water. That raw water gets split into the nitrate IX system and bypass, followed by radon air stripper and disinfection through a chlorine contact time and distributed to the public. One important thing to note here is that in the nitrate IX system, it works in tandem with a brine solution tank, and so that is used to regenerate the resin on site. So one of the very first steps taken towards PFAS treatment evaluations was to develop a basis of design. To do this, GHD first collected critical information from the client, like the water quality data, the treatment methods, the PFAS concentrations in past years, the nitrate removal system specifications, etc. And we also performed some new PFAS samples, and we did that at 3 locations within the existing plant, and that's the raw water, the nitrate IX effluent, and the finished water. And we also performed some top assay samples. So what did the data read? Essentially, what, like most of us might know, the nitrate resin wasn't able to meet the EPA standards, but it was able to remove some of the PFAS that was detected. And another observation we made was that over the years, the nitrate was being reduced. I think 3 years ago, it was 11 milligrams per liter, and it had been reducing at a consistent level, or reading at a consistent level at around 6 and 5 milligrams per liter. Another interesting thing that was noted was that 67% of the PFHXS was increasing, which is a short chain PFAS, and it's something for the client to know in the future. Now, they were mostly concerned with the PFOS and PFOA, but seeing as regulation is constantly changing and updating, it's something that we let the client know. All right, so overall, our basis of design was an accumulation of the data presented to us by the client, the state regulators, and our own samples, and with the overall goal of having nitrate below the 5 milligrams per liter and PFOA and PFOS being of 70 parts per trillion or less. All right, so for the treatment alternatives, that was our next phase. And essentially, we were evaluating technologies, specifically the ion exchange and the GAC, and seeing where in their existing system was the best positioning for this PFAS technology. And these are the 5 alternatives we came up with. So the first alternative was for the after the nitrate effluent plus bypass, which is what they're currently, how they currently operate. The second was for the nitrate effluent. The third was having ion exchange at the raw water. The fourth was having GAC treat raw water. And the last one was have GAC treat, have water be treated by GAC after the radon stripper effluent. Now, I can tell you right away that alternative 4 was not evaluated further when it came to the treatability testing because of the association with radon waste and potential disposal costs. And so that was not evaluated at our labs. However, 1, 2, 3, and 5 were evaluated. Okay, so our treatability testing occurred internally in our with our innovative technology group that we have with GHD. And what they did, they performed small scale column tests that were specifically testing manufacturer resin and carbon. So we had 2 resins that were being tested and 1 carbon that was being tested. And their job was essentially to determine which was the most effective empty bed contact time, the breakthrough and maximum loading, and determine the effectiveness of the treatment media, as well as provide recommendations based on the results achieved. All that work, which took several months, led to what you see here, which is that resin 1, 2, and 3 had the following empty bed contact times with the following results with PFOA and PFAS in combination. I like to point out that the GAC did have non-detect or did reach non-detect, and resin 1 was evaluated at 2 sample locations because the manufacturer had told us, had provided us with a projection performance that they were unable to meet at raw water. And so we proceeded with doing that same or reevaluating that media, that resin at a different sample location and derived similar projections to what they were stating. I'd like to point out that the resin 1 was disqualified at some point because there was a lot of miscommunication with the manufacturer, and the projections weren't being met. And they were also telling us that we needed to grind the resin to achieve the results, which didn't seem right to us. So in addition to that, like I said, there were other factors being taken into consideration. We compared the manufacturer performance projections, like I said, with our treatability testing. We provided a process flow schematic, as well as site layout and footprint and cost estimate. Now, we all know that GAC has more footprint than ion exchange, and just to provide a brief cost indication for these alternatives, resin 1 came out at 365,000, resin 2 about 29 because of resin 2 was associated with alternative 3, which I forgot to mention had the switch of nitrate resin with the PFAS resin. So it would be an automatically reduced cost on that behalf. And then for GAC, we had 502,000 for that cost. So overall, for the full-scale pilot test plan, we proposed to the client that they proceed with alternative 3, which was replacing the nitrate IX resin with the evaluated PFAS resin 2, which had an empty bed contact time of 3, And since that existing vessel had connections with regeneration, we requested them to disconnect that. And seeing as PFAS is constantly changing and currently they're meeting EPA standards and not state standards that may or may not be enacted within the next year or so, we proposed to them to have breakthrough targets at 10 parts per trillion, 35 parts per trillion, and 70 parts per trillion in case any changes were to occur. And lastly, we recommended to them that nitrate have be approved, the removal of nitrate treatment be approved by the state regulators, whether that should be removed or not from the system, seeing as the levels were reaching the required 5 milligrams per liter without treatment. Overall, like I said, we recommended resin 2, alternative 3. We also recommended to the client that they performed samples, monthly samples for PFAS, radon, and nitrate. The radon specifically because it hadn't been evaluated since it had been put in place. And so that along with the nitrate needed to be reevaluated to see if there was still a necessity for that treatment in their process. When it comes to the regeneration, it was unknown whether it contained PFAS and that was a potential source or whether if it was a potential source. So we recommended that they test their regenerant. And lastly, when it comes to reinstalling the nitrate system, because assuming that they do take our approach for alternative 3, which we would have to rethink that and see how it can how we can reintegrate nitrate if and also add a PFAS vessel in the future. So in conclusion, we were able to compare media performances with manufacturer provided medias. And we were also able to assess the sequence of the media and which worked best, either, for example, for the radon and for GAC, we determined that it had to be after the radon, and for nitrate, it would receive additional load. So we wanted the PFAS to be after the nitrate if the nitrate would still be in place. So long term, we are definitely concerned about, the reduction of PFOA and PFOS MCLs. And for this case study, we didn't focus on mitigating the PFAS sources, but that's something to take into consideration. And lastly, when it came to the client, we wanted to again reassess which were the best, which treatments were appropriate in this water treatment plant, to rethink or to reanalyze what alternatives were best for treating PFAS. That concludes the end of my presentation. Thank you for your time. And if you have any questions, please feel free to add it to the chat.
Yeah, we do have a minute for a question. Lee, are you monitoring the questions queue?
We have one question. For the radon buildup, was the problem radon or led to 10 decay product?
For the radon, could you say that again?
For the radon buildup, was the problem radon or led to decay product?
It was the radon. So,
oh,
sorry, go ahead.
No, go ahead.
I was just reading the next question.
Oh, yeah.
So the next question by John Scott was, how is the spent IX resin handled? So with regards to that, we had the client essentially disposed it at incinerated it.